Hello guys, welcome to the second part of the trigonometric ratios that we started before. It will be a part 2 and prepared by me, Ms. Salma Ahmed. What is a trigonometric ratios? I said it before that it is a relation between the angles and the sides for the right triangles. So I'm gonna repeat, it's very important to be a right triangles, not any other types of triangles. We are going to have 18.1 tangent ratios. So we are going to read together our objective. Understand that by similarity, side ratios in the right triangles are properties of the angles in the triangle, leading to the definitions of trigonometric ratios for acute angles. So how can we use the tangent ratios in and their inverses in calculations involving right triangles? The trigonometric ratios are, we took it before for the right triangle, that the sine theta is opposite over hypotenuse and cosine theta is adjacent over hypotenuse. So today we are going to have tan. So how can we find tan theta? Tan is sine theta over cosine theta. So if I'm going to replace sine theta by opposite over hypotenuse, and cosine theta adjacent over hypotenuse, so it will be opposite over hypotenuse divided by adjacent over hypotenuse. So I can't answer it like this, so I have to make the reciprocal of adjacent over hypotenuse after the divide and change the divide into multiply. So it will be opposite over hypotenuse times hypotenuse over adjacent. If we cancel hypotenuse with the hypotenuse down, so we will have the tan is equal opposite over adjacent. So this is the final rule that we are going to use for this lesson. Opposite over adjacent. First, find the tangent of an angle. Let's see this example. It will be in your books, page 932. Find the tangent of each specific angle. Write each ratio as a fraction and as a decimal rounded to the nearest hundredth. So I need to find for angle A and angle B. So I'm going to get the tangent for angle A and the tangent for angle B. So tan A, it will be opposite over adjacent. This is angle A, so this is the adjacent side and this is the opposite side. So I'm going to make opposite over adjacent, so it will be 18 over 24. So you're going to use your calculator to find it's 3 over 4 or 0.75 as decimal. Now we are going to move to angle B. Here is angle B, so the opposite it will be 24 and the adjacent equals 18. We are going to get the tan, so tan B is opposite over adjacent, where it is 24 over 18, and it gives me 4 over 3, which is approximately 1.33 to the nearest hundredth. More examples, page 933. Find the tangent for each specific angle. Write each ratio as decimal and as a fraction, as before. Round it to the nearest hundredth. Here we have this triangle and we have these three sides. Now I need to find angle Q and angle R. So tan Q, where is Q? This is Q, so it will be the opposite over adjacent, so 15 over 36. Yes, so it will be 15 over 36, which is 5 over 12. Using your calculator to the nearest hundredth, it will be 0.42. I'm going to get angle R. So tan angle R is 36 over 15. Here is R. So this is the opposite and this is the adjacent. So 35 divided 15, which is equal 12 over 5, which is 2.4. Second, find side length using tangent. When you know the length of a leg of a right triangle and the measure of one of the acute angles, you can use the tangent to find the length of the other leg. You can use tangent to solve real life situations. Example 2a, page 933. Apply the tangent ratio to find the unknown length. So here we have an unknown side and I need to find it. A roof contractor determines that she must place the base of her ladder 6 feet away from the house, making an angle 76 degrees with the ground to the nearest tenth of a foot. How far about the ground is the eave of the roof? So I need to find BC. So the answer, what's the relation between the angle that he is giving to me and the side that he needs to find? It's the opposite. So I'm going to use the tangent to find opposite over adjacent, as I know the adjacent, which is 6 feet. So tan, it will be opposite over adjacent, which is BC in the red line, over AC, or AB, sorry, which is as given in BA equals 6 feet and measure of angle A equals 76 degrees. So I'm going to substitute tan 76 equal BC over 6. So here I need to find BC. So I'm going to get the 6 beside the tan there. From the denominator, I'm going to move it here by times. So it will be 6 times 10, 76 degrees equal BC. So the answer for the BC or the side, it will be 24.1 to the nearest tenth, as he said. Another example, 2b, page 934. For right triangle STU, what is the length of the leg adjacent to S? Adjacent to S, and it means he needs SU. So I'm going to find the adjacent angle. 10S equal opposite over adjacent, which is TU over SU. So I know in the TU equal 87 and the measure of angle S is 54. So I'm going to substitute in the tan 54 equals 87 over SU. I need to find this SU, so I'm going to get it on the other side here and replace the tan 54 to be in the denominator. So it will be SU equal 87 over tan 54. By using your calculator, you can find an SU by the approximation 63.2 to the nearest tenth. Your turn in page 934. A ladder needs to reach the second story window, which is 10 feet above the ground, and make an angle with the ground of 70 degrees. How far out from the building does the base of the ladder need to be positioned? So this question actually it's not with a drawing, so we are going to try to draw it. Here we have a triangle and it's above the ground by 10 and the angle with the ground is 70 degrees. I need to find how far the ladder it will be placed. So I'm going to find X. So tan 70 is equal opposite over adjacent. So this is side in front of 70, which is opposite over adjacent. So it will be 10 over X. So X here, I want to get X, so I'm going to replace the X up and take tan 70 to be in the denominator. So it will be 10 over tan 70 degrees. By using your calculator, it will be approximately 3.6 to the nearest tenth. Third, find an angle measures using a tangent. To find an angle, we will use the inverse trigonometric ratios as we said before. So as the following example that I have here a triangle. So I need to find measure of angle J. So it will be opposite over adjacent. I'm going to use tan. So tan J equals opposite over adjacent, which is 46 over 93. And I need to get measure of angle J alone. So I need to move this tan to the other side by the inverse tan. So it will be 10 to the power -1, or we call it inverse 10, 46 over 93, and you can find this inside your calculator. By using your calculator, you're going to write it down. It will be 26.318. By approximating it to the nearest degree, as it is a measure of angle, so the 3 will not push the 6 anymore, so it will be 26 degrees only. So measure of angle J is 26. Thank you for watching and waiting for your questions if you have. Let me know if you need something. Thank you very much.